In this video for trig, we're going to talk about amplitude and reflections. So amplitude is basically the height of a wave. So amplitude, all we mean by that word is the height, let's say from the baseline. And we'll see what this means in a second. Oops. Not baseline, baseline. And when we talk about reflections, there are different types of reflections that you can have for functions. But the one we're going to be concerned with in this video is reflections across the x-axis. Okay, so that's what we'll discuss in this video, amplitude and reflections across the x-axis. So to begin that discussion, let's go ahead and look at a graph we know and love. Y equals sine of x, right? Let's take a look at that now. So the top graph here, this graph is sine, and notice that sine, it rises and then it falls, and then it rises and it falls, and it keeps doing that. And notice, of course, when x is 0, y is 0. When x is pi over 2, y is 1. When x is pi, y is 0. When x is 3 pi over 2, y is negative 1. And when x is 2 pi, we're back at 0. So let's first discuss amplitude. Amplitude, I said, was the height of the wave from the baseline. Now the baseline is the midway between the low and the high. So this is the low, right? The low's at negative 1. And the high is up here, right, at positive 1. So this right here would be the baseline for this graph. So the distance from, or the height, from this baseline to the top of the wave, that's the amplitude. Okay, so when we talk about the amplitude, we don't mean the total, we don't mean from the low to the high. We just mean from the baseline to the high. That distance is amplitude. Let's write that here. Let me put a little arrow here indicating, so from there to there. That is the amplitude. Okay, and the amplitude is a height or a distance, so it's always positive. So in this case, the amplitude is equal to positive 1. So let's go ahead and graph, and I created a couple two sets of axes below this top graph because we're going to look at some transformations of y equals sine. Let's first look at y equals 2 times sine. So let's write that here. Y is equal to 2 multiplied by sine. Okay. Now if you consider that function, and we're going to graph it here, what's it basically doing? Well, it's saying the y-coordinate is no longer just sine. It's 2 times sine. So you basically take the outputs that you had before, right, which were just from sine, and then you double those. So what basically is going to happen is we're going to get all the y-coordinates that we had for this graph, right, but we're going to double them. So for example, instead of 1, right, at pi over 2, we're going to get 2 because we're going to double that. Now at 0, when you double that, you still get 0. So what's basically going to happen is the graph is going to be sort of stretched. In other words, the effect of this 2 is to change the amplitude. Okay, so the number in front of the trig function, in this case the 2, the absolute value of that number gives you the amplitude. So let me put a little arrow here, that number, the absolute value, so let me write absolute value of 2 is 2, and that's the amplitude. And I'm just doing the absolute value because we're going to see in a moment when that number is negative, all you do is simply still take the absolute value because you always want a positive number for the amplitude. So let's go ahead and plot a few points before we draw on the graph. So remember, we're doubling the outputs that we had before. That's all that's changed, right? We're simply doubling the y-coordinates of the previous function. So let's see, when you double 0, well, you're still at 0. And as we mentioned, when you double 1, right? When you double 1, you get to 2. So here we have to scale up, right? We have to go, okay, let's go to 2. And then we're, of course, going to go to negative 2 as well in a minute. So at pi over 2, instead of getting 1, at pi over 2, now we get 2. So there's going to be a point up here. And then let's see, at pi we got 0. When you double that, you still have 0. And then let's see, at 3 pi over 2, right, the y used to be negative 1. But then you double that negative 1 and you get negative 2. So now you're way down here, like so. And then doubling 0 again, like, gives you that point. Okay, so the wave is going to look like boom, right? It's going to be a large amplitude wave. And likewise, all these are going to be doubled as well, right? Instead of negative 1, it's going to be negative 2. Throw it in. Instead of, well, still at 0. Instead of positive 1, it's going to be positive 2. So up here. and then 0. Okay, so let's go ahead and sketch that wave in now, the effect of doubling the amplitude. So there we go. It looks a lot like the previous wave that we had before, but now it's been sort of stretched vertically, if you will. An amplitude of 2. Let's write that in. So the amplitude, now the arrow is a lot taller, right? Amplitude equals 2. Now it's worth pointing out that the range of the original function, right, the range of sine is negative 1 to 1. The y-coordinates go from negative 1 to 1. What would the range be for the second function? Well, no longer negative 1 to 1, but it would be negative 2 inclusive to positive 2. And just so you know, in future classes like in calculus, for example, the fact that the range is negative 1 to 1 of sine, that leads us to the inequality for sine. People often write this. Sine x is less than or equal to 1 and greater than or equal to negative 1. That's just a reflection of the fact that its range is negative 1 to 1. Now, this inequality gets used quite a bit, so be looking for that in calculus. Okay, so there's one more transformation I want to talk with you about, and it has to do with when there is a reflection across the x-axis as well. Let's go ahead and graph a function down here, and that function is going to be this. Y equals negative 3 times sine x. So all I've done is I've taken the original sine and now I'm multiplying it by negative 3. And so, well, we can see there's a number in front, so that's going to affect the amplitude just like before. So now we say, okay, the absolute value of negative 3, that's positive 3, right? So the amplitude now is positive 3. So that means, well, instead of rising, not 1 or 2, now it's going to rise 3, right? So it's going to be a really large amplitude wave. But there's also this negative here. Now think for a moment what that means. Well, you take what you used to have, you multiply it by 3, then you multiply that by negative 1. And so the effect, for example, is going to be not just to give us 3 up here, right? That would have been what we got if there was no negative here. We would have just had a positive 3 up here. But if you then multiply that by a negative 1, what's going to happen? Well, instead of getting a positive 3, you're going to get a negative 3 at pi over 2. And that's what we mean by a reflection across the x-axis. All the y-coordinates are going to switch sign, basically, because of the negative there. So let's go ahead and write that in as well, that the little negative is responsible for a reflection. So we have a reflection across the x-axis. And that is because, let's see if I can draw an arrow like this. That is because of the negative right there. It's not because of the 3, it's because of the negative. So that means, first of all, we're going to have to scale this axis, right? So let's go up to 3. So 2, 3. And then let's see, negative 2, negative 3. Okay, and as we said, so basically multiply the values by negative 3. If you multiply 0 by negative 3, you're still at 0. But here we used to get 1. And if you multiply that by negative 3, well, you're not going to get positive 3, right? You're going to get negative 3, as we mentioned. So the first point, that is at pi over 2, is going to be way down there. And then if you multiply, 0, the y-coordinate of 0 by negative 3, you're still at 0. And so if I multiply, 3 pi over 2, if I multiply that, I used to get a negative 1, right? But now if you multiply that negative 1 that you used to get by negative 3, well, now at 3 pi over 2, you're going to get positive 3. That's the whole point. You're multiplying the old y-coordinates by whatever number is there. And then finally, at 2 pi, you're at 0. Okay, and the same thing is happening on the other side, right? You used to get, here at pi over 2, you used to get negative 1. Now you're going to get positive 3. And when I say used to get, I meant from the original graph of sine. And then at pi, still 0. 3 pi over 2 is going to be negative 3. And then at 0. Okay, so let's go ahead and plot, graph in, fill in that graph, and see our new graph of sine, or negative 3 times sine. Okay, there we go. Pretty exciting graph, and I can see, first of all, that the amplitude, right? Remember, the amplitude is positive, so the amplitude is positive 3. So the range is negative 3 to 3. but it looks slightly different than the other graphs, and that's because it's been inverted, right? There's been a reflection. Instead of a peak, I have a trough. But we still have two cycles, right? There's the first cycle, and there's the second cycle. Okay, so we talked about in this video amplitude and reflections, and we'll see other transformations as we proceed. Until next time.